what we are going through is first is nanoparticles, nanomaterials, like that. So what? Why is this much interest? Because the same thing I said to you, due to the unusual mechanical, electrical, optical, and magnetic properties of these materials have created a high interest in recent years. So what are the types of nanoparticle materials we can have? We can have ceramics, semiconductors, semiconductor Q particles, nanostructured semiconductors. So these advances in nanoscience has made us to use these materials at very vast applications. Okay. So why? What is the specificity of these different variety of nanomaterials? That is the next question. When you go for nanophase ceramics, what is a ceramic? It is nothing but a material made of clay which was hardened by heat. Okay. Why we go for nanophase ceramics? Why? Because at a very high temperature, that is a very elevated temperatures, what happens? This ceramic is become more ductile when you compare to a coarse grained ceramics. So it can be used for many applications. Okay. And why we go for nanostructured semiconductors? Semiconductors, normally it is used in electrical engineering, though it can be enhanced by nanostructured particles showing nonlinear optical properties. And when the same semiconductor was confined as a quantum dots, it will possess a special properties like luminescence property and like infrared optoelectronic devices. So this type of applications, for this type of applications, this semiconductor Q particles can be used. And also this nanostructured semiconductors can be used as window layers in solar cells. So as the nanoparticles has its application in electrical engineering, electronics engineering, and also in biomedical engineering due to the different types of materials. Okay. And there are some other metallic powders is also there. So it has been used for the production of gas type materials, and you have a porous coating, and this nano-sized metallic properties are used or enhances its ductility when the technique that is cold welding property. What is this cold welding property? It is nothing but the process of having welding process, that is the process of welding a material by means of a cold technique, that is without producing much heat. So when this combines with the nano-sized metallic powders, they can be used for metal-metal bonding, mainly in electronic industry. So these are all the introductions to different types of materials that we are manufacturing or synthesizing using this nanoscience. And when we go for single nano-sized magnetic properties, sorry, particles, and they have the special property that can be used for super paramagnetism behavior. And next we go for magnetic nanocomposites, where this have the mechanical force that is useful for high density information storage and magnetic refrigeration. Okay, right. So likewise, you can categorize many nanostructured particles as a metal, as a ceramic, as a semiconductor, as a metal oxide, as a silicon film, as a polymer, as a nanocomposite. So each one has its own specific property, and that specific property lead it to different applications. Likewise, as an example, I can say that these nanostructured metal clusters can be used in catalytic applications, and metal oxide thin films can be used for the realization of gas sensors so that it will have the sensor sensitivity and selectivity in used forms. When we go for nanocrystalline silicon films, okay, it can be used for high transmission and it can be used in dye sensitized solar cells. And next we go for nano While we have polymer based composites with a very high content of inorganic particles, it has a very high electric constant value, so that this made it applicable for photonic band gap structures. Yes. So these are all the different types of nanoparticles that have its own specific property. Depending on that property, we can apply for different types of applications. What is the main influence on the properties that was enhanced by nanostructure induced effects? There are two main properties. One is the small size. Okay. Another one is nothing but it is due to the yes, it is due to the surface or interface induced effect. So one is the small size, and that small size strongly influence the properties of the particles as a whole. And another one is nothing but the surface area, so that the crystallization behavior is quite different from micron sized powders or thin films. Okay, so you can say that if it is possible to form the nanoparticle even at moderately high temperatures. So these two induced effects makes the nanostructure particle to have in line in our recent advances in nanoscience. So the size effect in here, it can be reduced to the quantum size effect, so that the normal bulk electronic structure can be replaced by a discrete electronic levels. Okay, and the next one is the surface or interface induced effect. Okay, which is because of the enormous increased specific area in particle system, it can be used. It can be able to give a very different property for wide variety of applications. Okay, so the size effect is considered to describe the physical properties, whereas the surface or interface induced effect play a prominent role for chemical processing. Okay, so these are all the two induced effects which we have to keep it in mind while we synthesize the nanoparticle. For example, I can say that everyone in the lab, there are many methods to synthesize these nanoparticles, but one person will have a solution, and that solution they will wish to grow in a nano size, but they can't get it. There may be a failures like this. Why this happens? Due to them some phenomena problem, or due to the quantity of precursors we have taken. So in order to tackle with these things, what we have to do is, before itself we have to see the experimental evidences. Okay, experimental evidences. We have to do it. Okay, so the surface induced effect can be evidently made by the measurement of thermodynamic properties. Like we have to know the vapor pressure, we have to know the specific heat, we have to know the thermal conductivity and the melting point of small metallic particles. So, based on the size effect and the surface or interface induced effect, the nanostructure can be distinguished in this way. Yes. Next, I have a question that whether this nanotechnology was recently when came into existence. So the answer to this question is no. Why? Because the history of nanotechnology is from far away back. Mainly, it is a way it was being used from the Romanians. So the best evidence for the Romanian usage that the literature has got is from the British Museum collection. That is mainly the Likargus cup. What is this Likargus cup? It is nothing but a dichroic glass. Okay, so this is a phenomena, one of the phenomena used here. That is, it describes two different types of glasses that changes the colors in certain lightning conditions. In certain lightning conditions. Okay, so how this happens? How they They have done a very on that earlier days itself they have enormous the color of the glass when it was two different colors. So this was analyzed. They analyzed the cup with the tunneling electron microscope. And when we analyzed the cup with the tunneling electron microscope, we see that there is a presence of nanoparticles of about 50 to 100 nanometer in diameter, of about 50 to 100 nanometer in diameter. So this is an evidence for the use of nanotechnology from the Romanians. Okay, so this was also continued, and they have also used in the church windows in the medieval period. And what is this dichroic glass means? It is nothing but having a combination of the silver and gold alloys. Okay, so these silver and gold alloys have been incorporated in the glass. So this was confirmed by the X-ray analysis, and they showed that it has been dispersed in a glass matrix in the ratio of 7 is to 3. Normally, while we use gold there, some copper also incorporated, it is of about 10 percentage. Okay, so due to the presence of nanoparticles, it has exhibited its property of dichroic glass. That is, the cup have two different colors. Okay, so if it will appear green, as I have shown in the first figure, it will appear green in direct light, and it will appear as red purple when light shines through the glass. Okay, so these are all the evidences so that we can say that nanotechnology is not only popular at the recent level, but it had been from the, if you take the history, it had been from the Romans. Okay, right. So these are all the studies that were carried out to say that how much gold particles if we incorporate in a glass and what is the light reflected. See, the figure 1 gives you the gold particles which was dispersed in a solid matrix, and if its size is 25 nanometer and the shape is sphere, the reflected color will be in red color. In the same way, if we have synthesized the nanoparticles of gold of 50 nanometer size, and if it is incorporated or dispersed in a solid matrix, you will get a green color. If you take 100 nanometer, you will have of a sphere size, you will get a orangish yellow color. Okay. So these are all the different categories of gold nanoparticles for different applications in a glass matrix. Likewise, when you take the silver particles, and when the silver nanoparticles of 100 nanometer size in sphere shape, it will reflect the yellow color. While it is in 40 nanometer, it will reflect the blue color. And while you take prism shaped silver nanoparticles dispersed in a glass matrix, the reflected color will be red. So these are all the studies that shows that the nano gold and silver particles have been used in for very applications from the olden days. See, the main doorstep for this nano field was given by Feynman, who told in a meeting that there is a plenty of room under the bottom. So this statement made us to investigate or to discover the nanoparticles using two approaches. One is called as the top-down approach, another one is called as the bottom-up approach. What is this top-down approach? Making the bulk materials down into the nano-sized particles is called as the top-down approach. That is what you can say by definition, the breaking down of bulk materials to get nano-sized particles. Okay, how it can be done? Most commonly done thing is precision engineering and lithography. So precision engineering is a field that can be used by in electronics industries during the entire production process. And lithography, it is nothing but a patterning of a surface by exposing to light, ions or electrons, or you can also deposit the materials on the desired matrix. Okay, so this is a top-down approach. And next one is the bottom-up approach. What is this bottom-up approach? Making the nano-sized particles of small particles, arranging it into to build up a nanostructure of a huge size. That is called as the bottom up approach. So you can say that by definition, the bottom up is the buildup of nanostructures from the bottom. That is atom by atom or molecule by molecule. You can arrange it. Okay, either by physical method or by the chemical method, but it should be in a nanoscale range. So this can be done by many processes. One is the chemical synthesis process, top down and bottom up approach. You can say here that the top down approach can be used for the synthesis of nanoparticles through mechanical process, thermal process, optical process, scattering process, chemical synthesis. Okay. Likewise, you can approach. Yes.
PPT is not visible, ma'am.
Okay. Now is it visible?
Visible, ma'am.
Yes, ma'am.
Now is it visible?
Yes, ma'am. Yes, ma'am.
Okay, fine. Shall I start continuing?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, so top-down approaches can be used, can be done through mechanical process, thermal process, optical process, scattering method, and chemical etching method. Whereas the bottom-up method approaches can be done by vapor deposition method, sol gel method, chemical method, electrochemical method, bioreduction, atomic or molecular condensation method. So these
பிரசன்டேஷன்
are
தான்
the
போயிட்டு இருக்கு.
various categories of
சவுண்ட் கம்மியா போயிட்டு.
synthesis
ம்ஹும்.
method that can be
நீ இங்க
incorporated for
பேசினது எனக்கு அதுல
synthesis of
கேட்டுச்சா?
nanoparticles
அது இங்க
in
அதான்
these
தெரியல.
two different
அது
approaches.
இப்ப கேட்டுச்சு எனக்கு. சரி இதுல
So
ஏதாவது
I'm not
அன்மியூட்ல
going
இருக்கான்னு
to have
பாக்கலாம்.
a detail about it because
மியூட்ல தான் இருக்கு.
already you had a class on that. So I now go for the advances in science. Okay. So these are all the phenomena, these are all the concepts, the properties of these nanoparticles made this nanoscience to have a wide application in vast areas of nanotechnology. Okay. So one by one, from the day-to-day life needs up to the high level needs of the world, the nanoscience is satisfying each and every one. So how it is from the day-to-day life, you can see a sunscreen. Okay, so if you take a sunscreen, normally before that bulk materials made sunscreens, while you apply on the face, it will have a white patch, right? As you can see in the figure, you can have a white patch. Okay, but when the same sunscreen is made of nanoparticles, what happens? It won't leave any white patches, so that the skin will be glowing transparently. So it is also one of the advances in nanoscience. And next is the self-cleaning glasses. So this self-cleaning glasses was mainly offered by a company called Pilkington. So they offered a product that is called as active glass. So in this active glass, they used the nanoparticles. So what is the main specific character of this active glass you see is the glass is photocatalytic and hydrophilic. So no, obviously what will happen if it is photocatalytic and hydrophilic, it will clear or it will clean the dust of its own. So this is called as self-cleaning glass. Next is the clothings. The clothings that were used by the persons in the labs. Okay, and also the scientists are using these nanoparticles to enhance their clothing. What happens? They have a clothing, and on that clothing, they will have a coating of zinc oxide nanoparticles. So, this coating will make them to protect from UV radiations, and also if you have any stain resistance, also that is it is a stain resistance, that is it won't um what to say, like lotus on the water, it will be like it ripples it. Okay, so that is what the main characteristic of nano clothing, zinc oxide nanoparticles. Okay, so these are all the normal advances in nanotechnology that made us to have some materials for our day-to-day life. And in that line, we can say that scratch resistant coatings. This scratch resistance coatings, we use the glasses for our eyes. So it may come for 6 months or for 1 year like that. So after that, what will happen? Definitely there will be a scratches. But if you have this nanoparticle coating, that is the aluminum silicate nanoparticles, if you have that coatings on your glass, it will be subjected to scratch resistance. Okay, so these coatings are more effective, and it increases the resistance to chipping and scratching. And also the scratch resistant coatings are not only used for eyeglasses, but also it is used in cars and also in other applications wherever it was required. And next comes the antimicrobial bandages. So what is this antimicrobial bandages? Normally what will happen if we take a wound on a person, if a person has a wound, what will happen? The blood flows out. Okay. After a certain time, what will happen? The blood flow gets stopped. So while you use this antimicrobial bandages, okay, so this bandages contains the silver nanoparticles. The silver nanoparticle mainly blocks the microbes. The cellular respiration slowly it gets stopped. It continue to stop. So what will happen after a certain time? That heart rate will increase significantly. So the main advantage of using antimicrobial bandages is that you can cure it in a very, very short time of seconds, short time. That is in the order of seconds. So that is the main advantage of using antimicrobial bandages. So in line with this, you can also say that swimming pool cleaners and disinfectants, the nanoparticle adhere the bacteria particles from the swimming pool, so that it will make the, what will happen actually is this nano sized oil particles will get adhered to bacteria. Okay, so that it will take the bacteria more efficiently by a enviro system, yes, developed. So
இது எனக்கு கேக்குது. யூடியூப் ஆன் பண்ணிட்டாங்க. ஒரு 5 நிமிஷம் வெயிட் பண்ணுங்க. ஏன்னா எனக்கு லேட்டா தான்
very much varied to such an extent, very light, but it is also stronger than steel. So in the same manner, the tennis ball is also introduced that have the coating of clay of nanoparticles. So the clay act as a sealant. That is, it can be very difficult for air to escape the ball. So in sports also, this nanoscience have paved its way and made the materials to handle in a very efficient manner. Okay, right. So we have seen the advances of nanoscience in our day-to-day life, in sports. What about in biomedical engineering? So main thing that is provoking most of the human beings nowadays is the cancer disease. So in the olden days, if a person had a cancer, then there won't be a treatment. Some persons will be able to cure it, and some won't have that much, so that they subject to a very short term lifetime or lifespan, you can say. So this nanoscience has made a drug delivery technology. So drug delivery technology has made the cure of cancer in a very efficient and effective manner. What is this drug delivery technology? So it is nothing but you're optimizing the nanoparticles, or you can say nanosystems, at the right time, and you're making or inhibiting that drug into a particular malignant cell, so that that malignant cell, that is the cancer cell, can be eradicated without damage to the adjacent normal cell. So this is a very important applications of nanoscience, you can say. And you can say that it has revolutionized the pharmaceuticals and biomedical industries in cancer therapies. So, and also it is very valuable. Why? Because it won't destroy the non-malignant cells. It will destroy only the cancer cells. That is the main specificity of the drug delivery technology that is optimized by nanosystems. Likewise, the resistant fabrics, deep penetrating cosmetics, liquid crystal displays, and you have any other facilities using nanotechnology. Okay, so that is endless and it is countless. So this nanotechnology was a very wide branch of science that ranging from Intel microprocessors to bio nano batteries are using these nanotechnology, and they are also using as a capacitors only of few nanometer thickness. Okay, so these are all the some basic applications or advances in nanoscience. Next come for energy field. Okay, what is this energy harvesting for self-powered nanosystems? So this is a another type of technology where the energy can be harvested by means of a self-powered nanosystems. So this is a type of device that is called as the self-powered nanosystem, where it converts the mechanical energy or the hydraulic energy into a electrical energy by its own. Okay, so this energy, you can ask the question, ma'am, you're using this energy. Why it will give that much efficient energy? Definitely. Why? Because the nano devices and nano systems are using this energy that are operated at a very low power. Okay, so the energy is harvested from the environment and it is sufficient to power a nano system. So this type of device is called as energy harvesting for self-powered nano systems. So the small amount of energy harvested can be used to operate a very say low powered nano systems. That is nano systems require very low power for its execution. As I said, these are all the advances in nanoscience. The next very unbelievable advances is the synthesis of carbon nanotubes. These nanotubes have been brought into the world from 1985 by the Robert Curl, Harold Kroll, and Advanc These are all the scientists. These three scientists, they discovered the carbon nanotubes. So these nanotubes are very suitable for very fullerene or buckings. Okay, due to its strength and flexibility, it is very potentially useful in many nanotechnologies and biomedical applications. technological applications. So the figure gives you the fullerene structure, and the same carbon can also be defined in a nanotube form in polymers. So using this carbon nanotubes have mechanical, thermal, and electrical properties of the bulk product. So this type of carbon nanotubes have its potential applications in field emitters, energy storage materials, as a catalyst, and also as a molecular electronics. Okay, so here the carbon atoms, close metal atoms together, and it can also form a new organic compound. Very on the carbon nanotubes, and in continuity to that, you can say that these carbon that is buckyballs or fullerenes have been developed in a vast ages that came into existence as a carbon dots in 2004 with the size below 10 nanometer. So you can say that C dots, that is carbon dots, is a rising star as a new nanocarbon member because of it abundant in nature and inexpensive. What is its main specific property? You can say that its toxicity is very low, and it have a very good biocompatibility. So these two properties of carbon dots made it favorable material for applications in bioimaging, biosensor, and drug delivery. Biosensors is nothing but it is an analytical device that is they are used for the detection or concentration of the chemical substances that combines a biological component with a physicochemical data. For example, you have to check the oxygen pulse. So as I have shown in the figure, so these are all called type of this type of devices comes under the category of biosensors. Next is bioimaging. What is bioimaging? It is nothing but an instrument that is used to take the or to acquire, process, and visualize the structural or functional images of the living objects. Right, living object you can. That is in general to say it is used to visualize the fixed biological sample. So likewise, based on their excellent optical and electronic properties, these carbon dots is also offer exciting opportunity for catalytic purposes, for energy conversion, photovoltaic devices, and nanoprobes for sensitive ion detection. So next, after the discovery of this in 2004, this carbon-based materials had been become a backbone for almost in every field of science and engineering. So there are many advances to say. So in the meantime, not only in the electrical field, electronic field, and biomedical field, and in day-to-day life, it also made its advances in computer science also. How it has made its advancement in computer science? You can be evident this from progress of the computer system to decrease the size from a normal computer, that is a room size, to the mobile laptops now in our place. So likewise, electrical engineers also progress to design the complex electrical circuits down to the nanoscale level. Okay, not only in computers technology, this nanoscience have paved a way to make smartphone technologies also. And it is very, very important for our modern electronic devices that we use in our day-to-day life. So the figure gives you the nanotech computer chip that is making that can be evoked after 2020. In future, your nanotech computer chip will looks like this. It is nothing but a nano generator, pocket powerhouse. You can have it in your pocket, and whenever you need a power, you can utilize it. So these are all the modern electronic devices that are making its advancement in future. Okay, so we have seen very common engineering fields. While we go for specific engineering fields, there are another two fields. That is, one is aerospace engineering, another one is artificial intelligence. While we speak about these two, while we speak about these two fields, we have to tell how this nanoscience and its advancement have paid its way in aerospace field and other fields. So while we look at aerospace fields, there also we use nanomaterials. That is, the aerospace materials can be designed in nano form. If we design it in nano form, it gives 100 times stronger specificity is it improves the fuel efficiency and also provides a safer and stronger materials for the aircrafts. Okay, while the nanoparticles is mixed with the polymer matrix, you have a very stronger material, and that material is also resistant to damages. The damages may be from UV rays or due to the moisture or due to lightning or delamination, whatever it may be. So particles are the nanomaterials has its good impact on the aerospace engineering also. So withstand high temperature and will have a better friction wear. Okay. So this nanomaterials, while we use it will ensure a airborne platform so that its operation is very superior and it this also prevents corrosion so that you will have the increase or efficient longevity of the platform. So these nanostructured metals, nanocomposites are employed in aerospace manufacturing. Okay. So next is comes the super flexible chips that can encircle a strand of hair. So it is the very major advancement. That is, we know hair how it looks. It is of very small nanometer in size. Okay, so a scientist, a Swiss scientist, he created a nanotech based electronic chip that can be wrapped around a hair or a, so why, what is the main thing here of concentration, so there is an issue to obtain a required composition and the ability to control the dimensionality. See, I told you in the beginning itself, the nanomaterials can be categorized as zero dimensional, one dimensional, two dimensional. So one dimensional nanoparticles will be helpful for specific applications, two dimensional. So that we have to control the modulation dimensionality. Okay, so that is the next issue. And while we assemble the nano-sized particles, we have to control the interaction between the particles as well as the architecture of the material. So these are all the issues that we face in synthesizing the nanomaterials. So it is not a quite good job, but challenging job. Okay, so synthesize and we have to better understand the influence of the size, and we have to understand the influence of the interfaces on the properties of nanostructured materials. And what are the other influences or development of concepts for nanostructured materials? And we have to investigate the catalytic applications, and we have to transfer the developed technologies into industrial applications, including the development of the industrial scale. So I can conclude by saying that nanotechnology and nanoscience is very fundamental and very important to industrial applications and medical field. So recent advances in the field of physics, chemistry, and material sciences have provided a number of nanomaterials with unique properties. And I can say that nanoscience is the boon to the future development in science, and nanoparticles and nanostructured materials is definitely give an active research area and techno-economic sector for its expansion of so I thank you one and all for your kind patience to listen my talk. Thank you. Thank,
Thank you, madam, and a nice presentation.
yes.
Now, question session. I request the student to raise your questions. Okay, fine. Let us conclude our today session. I must mention our deepest sense of appreciation for our today guest speaker, Dr. Ian Elufer, for her nice explanation of advancement in nanoscience. We are grateful to the today's speaker for demonstrating her knowledge in nanoscience and technology. We are all inspired by your great words, madam. Finally, I would like to take this opportunity to place on record our hearty thanks to SNH HOD Madam, Principal and Management for the perfect logistic support and guidance has extended to all of us at all. Thank you, Madam.
Thank you,
Thank you to
sir.
all presenters.
Yes. I also thank the management HOD of Nehru Institute of Engineering and Technology for giving me an opportunity to have my talk. Thank you, sir.
Thank you, ma'am. Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.